Okay, so first of all we start with the displacement diagram. So first of all, what is a displacement diagram? We already learned that this is a cam and profile, and the displacement of follower you can see here with respect to rotation. The cam is rotating. So in examples they have asked they give the requirement for theta 1 90 angle. For theta 1 90 angle, follower will move upside direction. After that, for 30 degree there will be dwell, and after that for 40 degree or 60 degree there will be returning of the follower, and after remaining angle of the cam, the follower should steady condition or dwell condition. So this type of requirement is given. So for that, first of all we have to make the displacement diagram. Okay, if you can't make the displacement diagram properly, there is always some mistakes in a cam profile. So this is the displacement diagram. What is indicating? It is indicating motion of follower with respect to rotation of cam. Means if I am saying that this cam is rotating, so for complete one revolution 360 degree, what will be the motion of follower in mm? Okay, so this is the displacement diagram. There are 4 types of displacement diagram is there. Okay, so you can see here, as the cam is rotating, this follower is moving upward, dwell, and returning, and again dwell. So this is the displacement diagram of follower with respect to rotation of cam, one rotation 360 degree. Okay, so we will study the types of this displacement diagram first. Okay, first of all we have this given data. Remember that this type of given data is always given. So there will be rise, lift, stroke of follower, which is denoted by S. So 40 mm is given, means during the rotation of this cam, follower will move maximum 40 mm. So it will move 40 mm upward direction, and during the rotation it will coming at a initial position and 40 mm backward. So this is the data is always given, and there is, you can see, rise angle 60 degree, means during this 60 degree of angle, so during this 60 degree follower will move upward direction. It is that's why it is known as a rise angle. After that there is a dwell, and for that 30 degree the follower will stay at a top condition, top position, and after that there is a returning angle, means after that 60 degree it will move downward direction, and remaining angle is for dwell angle. Okay, so let's start the displacement diagram and how we can make this displacement diagram. So first of all we are giving this graph or diagram which is gives us the respective follower motion with respect to rotation of cam. So there is in x direction we give the rotation, and rotation of cam is a 360 for one revolution. So all this angle we convert into this linear dimension. 20 degree is equal to, we have taken 1 centimeter. So we can draw the 18 semi, because one revolution is equal to 360 degree. For one revolution of cam there is a 360 degree, and if we want to draw the whole 360 we have to change the scale. Okay, so 20 degree is equal to 1 centimeter, so 360 is equal to 18 centimeter. Okay, so first of all we have to make here 18 centimeter. Okay, 18 centimeter line. Okay, and what will be the height of this rectangle? Means this height of this rectangle will be same as, remember that, same as lift. Means 18 semi is fixed, because rotation of cam is always 360, and scale we have taken constant. Every time we will take this scale 20 degrees equal to 1 centimeter. So 18 semi always we take this 1 centimeter. Okay, but what will be the height? Height is totally depend on the lift. So we will take the height is equal to 4 centimeter. Okay, and we will complete this box. So first thing in a displacement diagram is always make rectangle 18 by lift. Remember that it is a lift. So always make rectangle 18 by whatever the lift is given. And after that we will part this rectangle in a 4 part as per given angle. 4 angle is given, theta 1, 2, 3 and 4. As per that we will part this rectangle. You can see that there is a 60 angle is given and 20 degree is equal to 1 centimeter. So we will take one first part is how many? 60 degree is equal to 3 centimeter. So this will be 3 centimeter first part. After that you can see here this distance will be 3 centimeter. This is our first time, so I am writing here 3 centimeter. After that I am going to for second part. You can see here theta 2 is equal to 30 degree and our scale is a 20 is equal to 1 centimeter. So second part will be 1.5. Okay, so here our second part will be 1.5 centimeter. Okay, you can see our third angle is a 60 degree, scale is a 20 degree is equal to 1 centimeter. So what will be our, so that will be again 3 centimeter. Okay, so that's, and after that all remaining will be dual. So these are the 4 parts which have we divided with respect to angles. And if you measure this distance, what you will find, this distance will be, you can check 18 minus this 7.5. So this is the, first of all always remember that 4 part of this whole rectangle, and after that we have to divide rise and return into again 6 other parts. 6 parts of rise and 6 parts of return. So rise angle, this is a 3 centimeter. So 6 part means there will be 0.5 distance between. So this 6 part is there. This is all are approximately I am taking here because there is a no scale. So 6 part of rise and 6 part of return. We are not going to do anything in a dual angle. You can see, check here, this is the dual angle 30 and 210. So in this area you are not going to do anything. So we don't need anything to do in this area. Okay, so after that you will give all numbers here. Now you are going to number these points, like is a 0, 1, 2, 3, 4, 5, 6, 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. So you will give number all these points, means 0 dash, 0 dash to 6 dash, and same as here 0 and 6 dash, sorry 0 to 6. Okay, and after that you can check here, we are going to this displacement diagram according to uniform velocity. And in uniform velocity what you are going to do, we have to make here one line. Okay, means from 0 to this point, and this is the dual, and after that we this. So this light blue line, you can say there is a displacement diagram with respect to uniform velocity. You have to remember this. And we locate all these points here. This is the A, this point is a B, intersecting point with a horizontal to inclined. These points are considered as a C, D, E, F, G, and again here H, I, J, K, L, M, N up to N. So this is the displacement diagram I am going to show you. Okay, so you can see here you have to first make the rectangle, In that you have to part 60, 30, 60, because you know that we have taken scale as a 20 degrees to 1 centimeter. So total distance will be here. This is a 3 centimeter. Okay, and 1.5 centimeter. Okay.